closely at a rainbow the next time you see one. Red, orange, yellow, green, blue, indigo, violet. A perfect natural spectrum, or so it seems. But there is a strange absence hiding in plain sight. One familiar color never appears in the rainbow at all. Not because it is rare, not because it is faint, but because, in a very real scientific sense, it does not exist in nature's spectrum. Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world. That color is magenta. At first, this sounds absurd. Magenta is everywhere, in flowers, neon signs, digital screens, fashion, and art. How can something so common be missing from one of nature's most iconic displays of color? To understand this paradox, we must first understand what a rainbow actually is. A rainbow is not a collection of arbitrary colors. It is a physical map of visible light, ordered strictly by wavelength. Each color corresponds to light vibrating at a specific frequency. Red has the longest wavelength, violet the shortest, and every other color falls neatly in between. This sequence is linear. It has a beginning and an end, and crucially, nothing exists beyond those ends. Magenta is the problem. Unlike red or green or blue, magenta has no single wavelength. There is no point in the electromagnetic spectrum where magenta light resides. You cannot isolate magenta with a prism. You cannot measure it as a standalone frequency. In physics, magenta is called a non-spectral color. So where does it come from? The answer lies not in light itself, but in your brain. Human vision relies on 3 types of cone cells in the retina, roughly sensitive to red, green, and blue light. When a single wavelength hits your eyes, these cones respond in specific ratios, and your brain interprets the signal as a color. But sometimes light does not arrive as a single wavelength. When red light and blue or violet light reach your eyes at the same time, something unusual happens. There is no green in between, which normally acts as a bridge across the spectrum. The brain encounters a signal pattern it cannot place along its usual linear scale, so it improvises. Instead of seeing red plus blue, the brain generates a brand new perception to resolve the conflict. That perception is magenta. In other words, magenta is not a color that exists out there in light. It is a color that exists in here, inside the human nervous system. This also explains why magenta never appears in a rainbow. In a rainbow, red and violet are always separated by the full gradient of colors between them. They never overlap. They never strike your eyes together. And without that overlap, the brain has no reason to invent magenta. Interestingly, this is why color wheels are circular, even though the spectrum is not. Artists and designers place magenta between red and violet to reflect how we experience color, not how physics arranges it. The color wheel closes the loop that nature leaves open. Digital screens exploit this quirk perfectly. Your phone, laptop, and television do not display magenta light. They display red pixels and blue pixels simultaneously. Your brain does the rest. Magenta is, quite literally, a collaboration between technology and human perception. This raises a deeper question. If magenta feels real, if it evokes emotion, if it can be bright, dark, warm, or cold, does it matter that it has no wavelength? The story of magenta reminds us that color is not purely a property of the universe. It is also a property of the observer. What we see is not always what exists. Sometimes it is what the brain needs to make sense of reality. So the next time you see a rainbow, remember this: nature shows you everything it has. And yet one color is still missing. Not because it is impossible, but because it lives somewhere far more complex than the sky. It lives in you. If magenta exists only in the human brain, do you think it is less real than other colors, or does that make it even more fascinating? There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.